David Ken here. We're in topic 5.2. We're describing practical uses of potential divider circuits, including advantages of potential dividers over series resistors in controlling a simple circuit. So this question, we have a filament lamp that's rated at 12 volts and 6 milliamps. So we can put 12 volts across it and 6 milliamps through it. It just lights when the potential difference across it is 6 volts. Anything less than that, and you won't get enough current to light it up. We have a student who sets up this circuit to measure the IV characteristics of the bulb. In the circuit below, the student has connected the voltmeter and the ammeter incorrectly. Okay, so let's take a look at what's happening here. We want to measure the IV characteristics of the filament lamp, so what we want to do is we want to put different voltages across it and measure the different currents through it. So the idea behind using the voltage divider, or the potential divider, is that when we send current into the potential divider, we can tap out from it and get potentials between 0 and 12 volts. If we tap up at the top, very little of the potential will be burnt in the variable resistor before we get out, and we'll get 12 volts across. If we tap out down low, then almost all of the 12 volts will be burnt before we can run into the filament. That's how it's meant to work. But it's not going to work because of the way that the instruments are connected. First off, the voltmeter is connected in series, and voltmeters have very, very high resistances. As a result of that, effectively no current is going to flow through this branch at all. The lamp will never light. Current is meant to be measured in series, so it's okay that the ammeter is connected here, but it doesn't measure the current through the filament. We want the current and voltage characteristics of the filament, so the ammeter needs to be on this branch of the circuit, not that branch. Well, let's go on to answering the question now. The battery has an EMF 12 volts and negligible internal resistance. The ammeter has negligible internal resistance, and the resistance of the voltmeter is 100 kiloohms. The maximum resistance of the variable resistor, on the other hand, is just 15. So from there to there is 15 ohms. First, we're asked to explain, without doing any calculations, whether there's a position of the slide at which the lamp will be lit. And the answer is no. But we need to explain. The reason is that the voltmeter is connected incorrectly. It's incorrectly connected in series. Because it's incorrectly connected in series, its high resistance will prevent a significant current from flowing through the bulb. Part B asks us to estimate the maximum reading on the ammeter. So depending on where we put the slide, what will be the highest value that the ammeter reads? This is kind of a silly question. I'm not sure that I like this question so much because the circuit is connected incorrectly. Therefore, effectively no current is going to flow through this branch, no matter where we put it on the slide. I mean, we could put it all the way at the top, but then the current has a choice between a 15 ohm branch and a 100 kiloohm branch. I mean, some of the current will go through this branch, but so little of it that it's negligible, certainly if we're dealing with two significant figures. So really, we can imagine that this whole branch of the circuit is negligible. And so the maximum reading of the ammeter will be the only reading of the ammeter, and that's the reading of the ammeter associated with a 12 volt potential and a 15 ohm resistance. So V equals IR. I is V on R. We have 12 volts and 15 ohms, and that gives us 4/5 or 0.8 amps.